So here we have the periodic table of elements, which has every single element known to man on this planet. The periodic table is divided up into a whole bunch of different boxes that tells us a bunch of different things about each element. But the only things we're going to focus on are the letters inside each box, which is the name of the element, and the decimal numbers underneath it, which is the atomic mass. The atomic mass tells us how much one atom of that element weighs. The name tells us, well, the name of the element. So H stands for hydrogen, Li stands for lithium, Na stands for sodium, and so on and so forth. Now what we're going to do is we're going to divide up the periodic table, and by doing so we're going to cross this pink section out, cross this green section out, and cross column number 14 out as well. And what we're going to do is we're going to write the following numbers in the following columns. 1 in column number 1, plus 2 in column number 2, plus 3 in column number 13, minus 3 in column number 15, minus 2 in column number 16, and minus 1 in column number 17. Now, what these mean are the charges that each of these elements have in these columns. So, what charges tell us is how these elements are going to react with each other. A positive element could only react with a negative element. So I couldn't mix Li, which is lithium, with Al, aluminum. It just doesn't work like that. But what I could do is I could mix Li, lithium, with N, nitrogen. Why? Because lithium is positive and nitrogen is negative. So, what do these charges mean here? The plus charges tells me that there are tells me the amount of electrons in each atom of the element that we're talking about. More specifically, the outer shell. Many atoms have a bunch of shells, but we're only going to focus on the outer ones. The negative numbers tell me how many empty spaces there are in that outer shell that can be filled. So, for a quick recap now, what numbers do we assign to the following columns? Take a guess, let's see what you got. Good. So column 1 gets plus 1, column 2 plus 2, column 13 plus 3, skip this here, negative 3 for column 15, negative 2 for column 16, negative 1 for column 17. So for all the other elements in the periodic table, like here in the pink and the green, and in column number 14 over here, all these elements here, when they are found, they do not have an exact number of electrons in their outer shell. So what we have to do is that whenever we see these elements in use in a problem, we have to be given how many electrons it has in its outer shell. So if we're given C, which is carbon, over here in column number 14, we have to be told how many electrons are in its outer shell. So if I see C, Roman numeral 4, that means there are 4 electrons in its outer shell. That has to be told to me. I cannot assume what it has. Now we're going to talk about something called the diatomic pairs. The diatomic pairs are elements that when are alone in an equation are always going to have the number 2 at the bottom. I'll explain to you in a second what I mean by the number 2. But let me tell you what the diatomic pairs are. It's Br for bromine, Cl for chlorine, I for iodine, H for hydrogen, O for oxygen, N for nitrogen, and F for fluorine. Easiest way to remember it, or the way I do, is Brick-Lee-Hanf. Bromine, chlorine, iodine, hydrogen, oxygen, fluorine. So what I mean by the number 2 is we're going to take, let's just say bromine for example, and if it's left alone, we just see Br, we're automatically going to put a 2 at the bottom. What this 2 tells me is that when I see this element, it takes 2 atoms in order for it to be left alone. So 2 atoms of bromine are required for it to be left alone. Same thing with oxygen. We can't just have oxygen sitting by itself. It has to have another one of its atoms with it. So this subscript represents how many atoms are inside this given spot. This spot is called an ion. And we're going to get to those in just a second. But these are the diatomic pairs. Brick-Lee-Hanf. Don't forget them because you always need them. Now we're going to talk about ions. Ions and ionic compounds are when two elements come together to form something, which is an ionic compound. So what we're going to do here is we're going to take lithium, which remember has a charge of +1, and we're going to take oxygen, which is a charge of -2. Right now they are both ions, and they're going to form an ionic compound. So we have Li and oxygen. Lithium has a charge of +1, oxygen has a charge of -2. When putting two ions together, we have to find the greatest common factor between the two charges. So regardless of the positive and the negative, we're just going to focus on the number. The greatest common factor between 1 and 2 is 2. So what we have to do is we're going to have to multiply lithium by 2. And what I mean by that is that we're going to have to let people know that lithium is now going to have 2 atoms of lithium within it. So we're going to have Li2O. This 2 down here represents that there are 2 atoms of lithium in this ionic compound. Since there's nothing over here under the oxygen, that means that there is only 1 atom of oxygen in this ionic compound. Let's try another one. If I were to take sodium and nitrogen, I have Na, which is a charge of +1, and nitrogen, which is a charge of -3. The greatest common factor between these two is 3, which means I have to multiply the sodium by 3. So now I have sodium, 3, nitrogen. This 3 represents that there are 3 atoms of sodium in this ionic compound. Since there's nothing here underneath nitrogen, that means there's only 1 atom of nitrogen in this ionic compound. Let's try one more. We're going to take Mg magnesium and P phosphorus. Magnesium has a charge of +2. Phosphorus has a charge of -3. The greatest common factor between 2 and 3 is 6. So I have to multiply magnesium by 3 and phosphorus by 2. Now I have magnesium 3, phosphorus 2, meaning that there are 3 atoms of magnesium in this ionic compound and 2 atoms of phosphorus in this ionic compound. Now I'm going to give you a few to try. Take hydrogen and oxygen. Take sodium and chlorine. And then take magnesium and nitrogen. Put these together and tell me what you get. So what you should have come out with is the following. Hydrogen has a charge of +1, oxygen has a charge of -2. Greatest common factor is 2, therefore it's H2O. Sodium has a charge of +1, chlorine has a charge of -1. The greatest common factor between them is 1. Therefore, there's nothing to multiply. We just leave it as so. Magnesium has a charge of +2. Nitrogen has a charge of -3. The greatest common factor between them is 6. So I have to multiply magnesium by 3 and nitrogen by 2. And there you have it. You just formed an ionic compound. Now we're going to learn how to balance an equation, a chemical equation. If you've done algebra before, then this should be a breeze to you, because it's the exact same thing. What we're going to do is we're going to take the ions that we formed in our last little clip, and we're going to make them into a compound. So I'm taking hydrogen, nitrogen, and it's going to form nitrogen-hydrogen mix. So, like I said about the diatomic pairs, nitrogen and hydrogen are diatomic pairs, meaning that they have to have 2 atoms of themselves when they are alone. So since nitrogen is alone here and hydrogen is alone here, we have to make them diatomic. Now, when it comes to balancing an equation, what we're going to do is we're going to make sure that the same amount of atoms are equal to each side of the equation. So on the left side over here, we've got 2 atoms of nitrogen. But on the right side, we've only got 1 atom of nitrogen. So what we have to do is make 2 atoms of nitrogen appear on the right. And the way we're going to do that is by multiplying nitrogen by 2. Now that the 2 multiplies over to the nitrogen, it gives us 2 atoms on the right. So now we're equal when it comes to nitrogen. Now we're going to have to balance hydrogen. As a rule of thumb that you should always use, balance hydrogen and oxygen last. It just makes things easier, and you'll see why later. So, now we have 2 hydrogen on the left, but on the right we have 6 hydrogen. This 2 multiplies over to the 3, which now gives us 6 hydrogen on the right. So in order to balance it out, we must multiply the hydrogen on the left by 3 in order to get 6 hydrogen on both sides. So now let's go back and see if we did it right. We've got N2 plus 3H2 makes 2NH3. We have 2 nitrogens on the left, 2 nitrogens on the right. 6 hydrogens on the left, 6 hydrogens on the right. This equation is now balanced. Let's try another one. We're going to do sodium chloride plus fluorine, which is going to produce sodium fluoride and chlorine. Now, what's the first thing that we're going to do? That's correct. We're going to mark our diatomic pairs. Fluorine is diatomic, so we're going to write a 2 underneath it. So is chlorine. We're going to write a 2 underneath it. We don't have to put the 2 underneath the chlorine here or the F here because it is with another ion. In this case, it's sodium. It's not alone, therefore it does not need to be put as a diatomic. So now let's begin to balance. We've got 1 sodium on our left, 1 sodium on our right. We're good with the sodium. Let's go to the chlorine. We have 1 chlorine on our left, but 2 chlorine on our right. So what we're going to do is we're going to multiply the left one by 2, and now we have 2 chlorine on both sides. But now we have a problem. I now have 2 sodium on the left and only 1 on the right. So what I have to do now is multiply the right by 2 in order to give me my 2 sodiums. Now let's go to fluorine. I've got 2 fluorine on my left and 2 fluorine on my right. So let's see if this is balanced and double check. We have 2 sodium chloride plus fluorine, which makes 2 sodium fluoride and chlorine. I've got 2 sodium on my left, 2 sodium on my right. I have 2 chlorine on my left, 2 chlorine on my right. And I have 2 fluorine on my left and 2 fluorine on my right. This equation is now balanced. Now I'm going to give you one to try. Go ahead and see if you can figure this out. Remember everything that we've learned so far. So, hydrogen and oxygen are diatomic, so we're going to have to write in the 2. Now, let's begin to balance. I've got 2 hydrogen on my left, 2 hydrogen on my right. Hydrogen's good. But I have 2 oxygen on my left and only 1 oxygen on my right. So what I have to do is multiply my oxygen over on the right by 2, and now I have my 2 oxygen. But now I have 4 oxygen on the right and only 2 oxygen on the left. I'm sorry, 2 hydrogen on the left and 4 hydrogen on the right. So what I have to do now is multiply the hydrogen on the left by 2 to give me 4 hydrogen on each side. Let's go back and double check and see if this is right. So 2 hydrogen plus oxygen is going to give 2H2O. I have 4 hydrogen on the left, 4 hydrogen on the right. 2 oxygen on the left, and 2 oxygen on the right. This equation is balanced. Very good. Now, remember those charges that we learned about the atoms and elements in each of those columns? Well, now we're going to use them. In the questions that I gave you before, I gave you the balanced ion compounds. But now I'm going to give them to you where you have to put in your own charges. So here we go. Let's give it a shot. So here we have sodium bromide plus calcium fluoride is going to produce sodium fluoride and calcium bromide. So what we're going to do is we're going to go and assign the charges to each individual one of the elements. So sodium has a charge of +1. Bromine has a charge of -1. Calcium has a charge of +2. And fluorine has a charge of -1. And we're going to do the same thing over here. So now that I've assigned the charges, we're going to go ahead now and make them into ionic compounds. And we're going to do that by finding the greatest common factor between the charges of each individual ionic compound. So the greatest common factor between 1 and 1 is 1. So NaBr stays the same. Greatest common factor between 2 and 1 is 2. So this is going to turn into calcium fluoride 2. And this is going to produce NaF, sodium fluoride, plus calcium bromide 2. Now we can balance. So, I've got 1 Na on my left, 1 Na on my right. I have 1 Br on my left, but 2 Brs on my right. So I have to multiply the one on my left by 2. Now I've got 2 sodiums on my left, but only 1 sodium on my right. So I have to multiply my right by 2. Now let's move to fluorine. I have 2 fluorines on my right and 2 fluorines on my left. So my equation is good for fluorine so far. Now I have to go to calcium. There's 1 calcium on my left 1 calcium on my right. I'm done. Let's go back and double check. So 2 sodium bromide plus calcium fluoride produces 2 sodium fluoride and calcium bromide 2. I have 2 sodiums on my left, 2 sodiums on my right. I have 2 bromines on my left, 2 bromines on my right. I have 1 calcium on my left, 1 calcium on my right, and I have 2 fluorines on my left and 2 fluorines on my right. This equation is now balanced. Now I'm going to give you one to try it. Plug in the charges and balance out the equation. So here, you're now going to have to put in the charges and balance out the equation. As you can see, there's a Roman numeral over here for carbon. Remember what we said about Roman numerals. See if you can figure out this problem. So let's try to solve it now. This Roman numeral 4 tells me that there are 4 electrons in the outer circle of the atom. So what I'm going to do is I'm going to assign this the charge of -4. And I'm going to assign the charge of hydrogen +1. The greatest common factor is 4. So it's going to turn into CH4. Oxygen is a diatomic pair. So it's automatically going to turn into 2 atoms of oxygen. Now this carbon over here is still the same as the one over here on the left. The only difference is that the carbon now is going to be +4. Since oxygen is negative. So it's going to be +4 for carbon, -2 for oxygen. The greatest common factor is 4, which is going to turn it into CO2. Hydrogen is +1, oxygen is -2. This is going to turn into H2O. Now let's balance. There's 1 carbon on the left, 1 carbon on the right. Let's go to hydrogen. There's 4 hydrogen on the left and 2 hydrogen on the right. So I have to multiply the right by 2. Now I have 4 hydrogen on each side. But now I have 4 oxygen on the right and only 2 oxygen on the left. So I have to multiply the oxygen on the left by 2 in order to give me 4 oxygen on each side. So now, let's double check our work. We have CH4 plus 2O2 makes CO2 plus 2H2O. 1 carbon on the left, 1 carbon on the right. 4 hydrogen on the left, 4 hydrogen on the right. 4 oxygen on the left, 2 and 4 oxygen on the right. This is now balanced. Good job. The next thing we're going to learn is complex ions. Complex ions are a group of ions put together and are going to be treated as if they were just a single ion. So if I look over here, this is my list of my complex ions. I have ammonium up top, cyanide, nitrate, acetate, bicarbonate, permanganate, hydroxide, sulfate, carbonate, chromate, dichromate, and phosphate. These complex ions are treated once again as if they were individual ions that you would find on the periodic table. And I'm about to show you what I mean by that. So let's take an equation, for example. So here is an equation of aluminum bromide plus potassium sulfate is going to produce potassium bromide and aluminum sulfate. First thing we'll do is let's assign our charges. Aluminum is +3, and bromine is -1. Potassium is +1, and SO4, as we saw in the complex ion card, is -2. Potassium, once again, is +1. Bromine is -1. Aluminum is +3. And sulfate is -2. When you have complex ions in your equation, what you want to do is put that complex ion in parentheses. Because what you do not want to do is confuse each individual element as if they were separate. So, in this case here, SO4 shares the charge of -2. You wouldn't go find the charge of sulfate and then the charge of oxygen. So, what we're going to do now is we're going to combine these two here based on the charge given for this complex ion, which is -2. Greatest common factor is 2, which makes potassium 2. We're going to keep the parentheses because it's going to help us in a second. SO4. And we just continue it like any other problem. AlBr3. This will produce potassium bromide and aluminum 2 SO4 3. Now, we're going to balance this as if it were any other equation. There's 1 aluminum on the left, but 2 on the right. So we're going to multiply the left by 2. Now we have 2 aluminums. I have 6 bromine on the left, and I've only got 1 on the right. So I have to multiply it by 6. I now have 6 potassium on the right, and 2 potassium on the left. So I have to multiply the potassium on the left by 3 in order to get 6 on both sides. Now, on my left, I have 3 SO4. The 3 distributes to the subscript that's outside of the parentheses, not to what's inside the parentheses. Because as I said, a complex ion is treated as if it were its own individual ion off the periodic table. So there's 3 SO4 on the left, there's 3 SO4 on the right. Let's check our equation. We have 2 aluminum bromide plus 3 potassium sulfate, which gives us 6 potassium bromide and aluminum sulfate. Two aluminums on the left, 2 aluminums on the right, 6 bromine on the left, 6 bromine on the right, 6 potassium on the left, 6 potassium on the right, 3 sulfate on the left, and 3 sulfate on the right. This equation is now balanced. See if you can solve this. Balance out the formula. So lead has a charge of +2, and hydroxide has a charge of -1. Hydrogen has a charge of +1, and chlorine has a charge of -1. Hydrogen has a charge of +1, oxygen has a charge of -2. Lead has a charge of +2, and chlorine has a charge of -1. Let's put the charges together now and balance out the equation. So we should have lead hydroxide 2 plus hydrogen chloride, which produces H2O. That 2 shouldn't have been there. That was a giveaway for you. Plus lead chloride. Now the next step is to balance out the equation. I have 1 lead on my left, 1 lead on my right. I have 1 chlorine on my left, but 2 chlorines on my right. So I have to multiply the left by 2 in order to balance out the chlorines. Now I'm going to move to hydrogen. Now, since in this case, hydroxide did not stick together, this is now when we're going to distribute this subscript to each individual ion of the complex ion. So, on my left, I have 2, 4 hydrogen. On my right, I only have 2. So I'm going to multiply the one on the right by 2. Now I have 4 hydrogen on each side. On my left, I have 2 oxygen. On my right, I have 2 oxygen. This equation is now balanced. Let's double check it. So we have lead hydroxide plus 2 hydrogen chloride produces 2 H2O plus lead chloride. 1 PB in my left, 1 PB in my right. 2 Cl on my left, 2 chlorine on my right. 4 hydrogen on my left, 4 hydrogen on my right. 2 oxygen on my left, 2 oxygen on my right. This equation is now balanced. The last thing we're going to learn about balancing equation is fractions. It is possible to have a fraction when balancing an equation, but the only time that any ion gets a fraction is one that is all alone. For example, so here's an example. I've got phosphorus and oxygen, which is going to equal phosphorus dioxide. So, what I have to do is I'm going to balance out the equation. I've got 2 phosphorus on my right, I have to make 2 on my left. But now I have 5 oxygen on my right and only 2 on my left. There's nothing I can multiply oxygen on my left to equal 5, or at least no whole number. So what I can do is write a fraction. I multiply the oxygen on my left by 5 over 2. It will give me 5 oxygen. This can only work for an ion that's all alone, such as oxygen. If oxygen, for instance, was with something else such as hydrogen, this would not be able to happen. Let me give you one to try out for yourself. See if you can try this one. It's not easy, but I think you can handle it. So the first thing we're going to do is take care of the carbon. There are 8 carbons on the left, but only 1 on the right. So I have to multiply the carbon on the right by 8. Now my carbons are equal. I'm now going to go to hydrogen. I have 18 hydrogen on the left, but only 2 on the right. In order to make them equal, I have to multiply the hydrogen on the right by 9. Which now gives me 18 hydrogen on both sides. Now I'm down to my oxygen. I have 16 oxygen plus 9 oxygen, which gives me 27 oxygen on the right. But over here on the left, no whole number multiplied by 2 can give me 27. So what I have to do is write a fraction. My fraction is going to be 27 over 2. 27 times 2 equals 54, divided by 2 is equal to 27. This would give me my 27 oxygen on both sides. So let's check the equation. We have 8 carbon, 18 hydrogen, plus 27 over 2 oxygen, which is going to create 8 carbon, 16 oxygen plus 18 hydrogen, 9 oxygen. 8 carbon on the left, 8 carbon on the right, 18 hydrogen on the left, 18 hydrogen on the right, 16, 27 oxygen on the right, 27 times 2 is 54 divided by 2 is equal to 27 oxygen on the left. This equation is now balanced. Let's start with single replacement. Single replacement means that one ion replaces another. So for example, we're going to do NaCl plus F2, which is going to give us NaFCl2. The fluorine replaced the chlorine, which gave us sodium fluoride. It changed the equation from sodium chloride to sodium fluoride. This is single replacement, when one ion replaces another. Double replacement is when two ions replace each other. So for example, aluminum bromide plus potassium sulfate produces potassium bromide, and aluminum sulfate. The easiest way to remember double replacement is the inners go together and the outers will go together. So, bromine and potassium went together to form potassium bromide, and aluminum and sulfate form together to make aluminum sulfate. That is double replacement when two ions replace each other. Synthesis is when a compound is made from its elements. So for example, nitrate plus hydrogen equals nitrogen hydroxide. Elements form to make one compound. If there is more than one compound on the right, then it is not synthesis. Synthesis must be written as such, where the elements are on the left and the final product is on the right. Decomposition is the exact opposite. So for example, potassium, chlorine, and oxygen break down into the ions of potassium chloride and oxygen. This is decomposition because one compound is breaking down into its elements or into its ions, which is potassium, chlorine, and oxygen. Combustion is when heat and oxygen are added to a compound, and the products of combustion are always CO2, H2O, and whatever else was being burned. So here's an example. C3H8 is going to combust. Immediately when someone says to you that something is going to combust, you automatically add oxygen to the left side of the equation, because without oxygen, nothing can combust. This is going to produce CO2 and H2O. H2O and CO2 are always products of combustion. This is what combustion is. The thing that is being burned, and the oxygen must always be on the left, and the products must always be on the right.